This video is on using the buffer template and applying it to a buffer problem. So this flowchart. All right, so let's go ahead and just start doing a couple examples. I just wanted to show how to match up these problems with this flowchart that's happening here. So let's do. I'll probably do like maybe 3 of these, and you can watch this just in case you forgot how this works. So you can just watch it whenever. So, all right, let's look at the first one. So we have propanoic acid, or letter A, we'll call it. So letter A, and we have propanoic acid. So step 1 on our flowchart is to dissociate. If it's a salt, strong acid, or strong base, we're going to dissociate it and identify the cation and anion as being either a strong acid, strong base, or a salt. So depending on what the cation and anion are, they could behave acidically or cause the solution to be alkaline. So step 1 for part A was propanoic acid, and that's all we had. So step 1 was to identify our ions, and so I'm gonna make a little chart. You guys don't really need to, but I would like to see you list them out, because that's the proper way to do this, is to first identify it and then follow it in these steps. Okay, so identify the ions, and we had propanoic acid, so C3H5O2, and then its identity. So this is a weak acid, and I tried to on these examples. It goes to R because I want to make sure you guys are able to go down each of these paths based on what their identities were in the solution. So you could have this case. This is actually what's happening right now. Is you could just have a weak acid. And that's what we have. We don't have anything else. We don't have a strong base with it. We don't have a strong acid. We don't have its conjugate. This is all we have, is this right here. So this is going to be us, is this pathway right here. All right, so step 2, so what will the ions do? So for this example, we have, we're in this column right here. So we don't have a conjugate. We don't have a strong acid and a weak base. So if we had like OH with this, then that would be this column, but we don't, so it's not this. And we don't have a strong acid and a weak acid. So if we had like HCl with our propanoic acid, then this would be us, but it's not. So this is the route that we're going to go. So it's just a simple ice table on this problem based on the identity. So it's going to be HC3, H5O2, and we'll show it dissociating. Okay, and we set up our ice table. This is it was 0.100 molar. These were zeros. This goes down by x, goes up by x. You guys know how to do all this by now. 0.100 minus x and x. So we have x squared over 0.100 minus x equals the Ka, which I think is 1.3 times 10 to the negative fifth. Okay, and then we solve this. We're going to use the assumption rule. I'm not going to actually type these in. The whole point of this video is to get you going down the right path on the flowchart. So, because this flowchart, it's meant to be totally generic, so it should be able to fit any buffer problem that you ever see. So that's why I have so many examples here, is I'm trying to get you to go down each one of these paths, and even within each path, there's subtle differences. So between the problems. So, and it really takes a lot of practice to pick up on all the little subtleties within the problems. So anyway, to continue the solution on this problem, our x value is going to be the H plus. So you'll get some number, negative log, the pH, and then we're done. So if you look at our flowchart, that's all this problem is, just the weak acid. So let's try something. Now I'm going to quickly just look at the next ones. So we completed this one. Okay, we completed that one. So now this one, on this one, we're just gonna have this is the conjugate base. So it's a conjugate base, so it's a weak base of the propanoic acid. Okay, so that's going to be on that one. All we have here is just the weak base. So we're going to be in this column again. So just like the one we just did, but we're going to have the conjugate this time on that one, and then you're done. So that's number letter B. Now this one right here is we have the weak acid and its conjugate. So that will be this one, this column. Okay, so the first two are going to be this column here. And then letter C is you have the weak acid and its conjugate. So you're gonna going down that route. All right. So now this one is a little bit different on this one. So we're gonna look at letter D and try that one out and see what happens. All right. So I'm going to erase this old problem. Let's get rid of that. And go ahead and try D. So step one is we're going to list everything there. So we have our propanoic acid. So HCl is added to propanoic acid, what we had at the beginning. So in step one, we're going to, this is where we identify and list our species. So we have propanoic acid, HC3H5O2. This is the acidic proton, by the way. And identify. So this is a weak acid, and to it we're adding HCl. And on our flowchart, it says to dissociate the salts. So we're going to dissociate this into H plus and a Cl minus. So the Cl minus is a spectator, and the H plus is a strong acid. So on this one, so I'm trying to show you guys how to take this template, and we're putting this template on our notebook paper, basically. Okay, or you could photocopy this and just keep doing each problem on one of these flowcharts, but you don't need to. I mean, that's a little bit, I think it's a little overboard. So I'm just trying to show you guys how to like write out all the species and list everything and identify, and then pick the correct path. So this time we have a weak acid and a strong acid. So it's a lot different than A and B. A and B, where you had the weak acid or the weak base, and that's all you had. That's not us, because we have a weak acid and a strong acid. So weak acid and its conjugate is this one. So that was actually part C, I believe. A strong acid and a weak base. So we have a strong acid and a weak acid. So we don't have this situation or that situation. So that's not us either. So the correct pathway we go is we have a strong acid and a weak acid. So what we're going to do is just ignore, so that's what this says, ignore the weak ones in most cases. So you may just watch out if the Ka is huge, like -2 or something, 10 to the -2, and your strong acid is really dilute, it can get complicated. But for the most part, you can pretty much just ignore the weak acid for the most part. Okay, so to solve this one, let's see how many moles we have. So it says we have 0.020 moles, and we have 1 liter of solution. So for this one, we're going to just ignore. So on step 2, the correct column we're in, we are in, so we just take the pH. I'll just give it a little label here. We're going to take the pH of just the strong acid, since we're in column 4. That's our situation right now. So we have 0.020 moles. I might have added an extra sig fig, possibly. And we have 1 liter of solution. So our molarity is 0.0200 molar H plus. So just pH, or negative log this, and then that's the pH. So I hope that's enough to get you started. You guys could email me if you have questions on how to do it. But as I really think that if you follow this in meticulous detail, and you follow this step 1, step 2, you do it in this order, especially if you have this situation. Notice I didn't do one of those. I did one in class. I did one that was just like this one. So check your notes on how I did it in class. But this one, after this one, depending on what you have on the F line, can lead you here, here, or here. But the purpose of this video was just to get you started on using this flowchart in case you found it confusing to go from the problems here on this side and showing the work in your notebook. So, and using this going off the template at the same time. All right, so that's the end of the video.